Look up on a clear night and see the Milky Way stretching across the sky. It is a vast, stable city of billions of stars spinning in absolute quiet harmony. For decades, our best models, supported by observations from instruments like the Hubble Space Telescope, told a straightforward story of how these cosmic cities were built. In the early universe, massive clouds of cold gas gradually condensed over eons, slowly igniting the first stars. According to this standard timeline, supermassive black holes came last. They were thought to be the final step in a galaxy's evolution, growing from the collapsed remnants of dead stars and feeding slowly in the center of an already crowded stellar metropolis. We operated under the assumption that the universe was constructed by light. The stars built the cosmic structures, and black holes were merely scavengers that moved in once the walls were already up. That timeline fractured when the James Webb Space Telescope opened its golden mirrors. Webb was designed to pierce through dense cosmic dust with infrared sensors, letting us see light emitted 13 billion years ago. In that ancient darkness, barely 500 million years after the Big Bang, Webb found structures that defied all our simulations. Astronomers call them red monsters and little red dots, immense, dust-obscured powerhouses that had already converted a massive portion of their gas into stars. One object in particular, known as Able 2744 QSO1, presented an impossible math problem. By measuring the rotation of gas around it, astronomers weighed the central supermassive black hole. The scale tipped at roughly 50 million times the mass of our Sun. This animated scale demonstrates the anomaly. In the modern universe, a central black hole is a tiny fraction of its host galaxy's total mass, but the gas surrounding QSO1 follows a perfect Keplerian orbit, proving the central black hole is actually heavier than all the stars in its young galaxy combined. The chronological order is backwards. The massive gravity well formed first, growing enormous before its galaxy existed. If these supermassive black holes predated the stars around them, they were never the parasites. They had to be the architects. To build a monster that fast, the early universe provided conditions we no longer see today. It was a much smaller, hyper-dense, and incredibly chaotic environment, packed with thick, heavy clouds of primordial hydrogen. Instead of waiting millions of years for a star to live, die, and collapse, some models suggest these clouds skipped the stellar phase entirely. Massive pockets of pristine gas collapsed under their own gravity, instantly forming heavy black hole seeds. These seeds were quickly buried inside even larger envelopes of gas, creating a theoretical object called a black hole star. Rather than nuclear fusion powering the core, the rapid feeding of the black hole itself generated the outward pressure to hold up the entire solar system-sized structure. As billions of tons of matter attempted to drain into the event horizon simultaneously, extreme friction superheated the swirling gas into a white-hot plasma. The black hole ignited into a quasar, a raging cosmic furnace glowing brighter than 1 trillion suns. By furiously devouring everything within their gravitational reach, these infant black holes became the most powerful, efficient engines of raw energy in cosmic history. That extreme energy output is exactly how the black hole builds a galaxy. As the spinning plasma disk reaches its critical capacity, intense magnetic fields reject a massive portion of the incoming matter. The black hole channels this rejected gas towards its poles, firing twin beams of raw energy into deep space at 99% light speed. These relativistic jets act as a sweeping cosmic thermostat. In these hydrodynamical simulation panels, dark central regions demonstrate how thermal outflows from the black hole physically clear away cold gas. As we move through the grid, the black hole's feedback turns cold blue gas into hot yellow gas, regulating the galaxy's temperature. Now we are looking at stellar density from that same simulation. When those high-speed jets slam into distant, stagnant pockets of cold gas, the impact compresses the material. The bright blue flares indicate immediate, massive shockwaves of starbirth. The black hole dictates when star formation pauses and where it accelerates. It decides the total mass and how the final structure settles. Over billions of years, the universe expanded. The dense, chaotic gas clouds dispersed, the fuel supply thinned out, and the violent era of the quasars finally burned down to an ember. Today, sitting quietly at the center of our own Milky Way is Sagittarius A star. At 4 million times the mass of our Sun, it is a sleeping giant that has long since finished its heavy construction work. In its youth, its immense gravity acted as the ultimate cosmic scaffolding. It gathered the drifting elements of the early universe, anchored them in place, and organized billions of erratic stars into a smooth, balanced orbit. The steady, quiet corner of the galaxy where our Sun resides, the exact stability required for a planet to form and for life to evolve, is a direct inheritance from that ancient, violent regulation. We exist because the darkness provided an anchor. We are the beneficiaries of cosmic chaos, living our quiet lives inside a house designed by monsters.
Guys, please subscribe my channel for more updates. Press the bell icon for latest notifications. And also subscribe for more informative video like this. Thank you.